Good morning, all. We'll just wait a few minutes for people to log on. So we'll just give it a couple minutes for more people to get online. Just give it a couple more minutes, just waiting for more people to log in. We'll just be a couple more minutes waiting for everyone to join us. Yeah, we're getting a few more people on. Just one more minute. Okay, great. Over to you, Jim.
Thanks, Maria. Hello all and welcome. I'm Jim Challenger and I'll be one of your presenters today. The webinar will take approximately 30 to 40 minutes while we run through the slides, videos and a couple of live crosses to our demo room. Excuse me. If you have any questions, please feel free to type them in the box and we'll endeavour to answer them at the end of the webinar. Richardson is an Australian family-owned company. We've been trading for over 90 years and our core business is assembly automation equipment. Currently have 14 plus employees, including 3 full-time service technicians, with offices in Brisbane, Sydney and Adelaide. The presentation is intended as an introduction to screw feeding. It's not an in-depth product review, but a guide to introduce you to the world of screw feeding, automation and possibilities. I've been involved with screw feeding for over 20 years. Single-handedly, it has the potential to transform your production if done well, not only increasing assembly speed, but reducing errors and operator fatigue. If you use fasteners to follow some guidelines, you will not get a bigger bang for your buck investment in assembly automation. Most people associate screw feeding with handheld systems, but it's much, much more. There's a wide range including fixtured and robotic solutions, and we can feed all manner of fasteners from screws, clips through to nuts. Screw feeders are broken into 2 types generally, handheld and fixtured. Handheld systems provide a relatively low-cost way of increasing throughput without the need for rejigging or guarding, but they are generally manufactured to handle just one type of screw and they have limitations. Fixtured systems are usually incorporated into an assembly cell, whether that's a simple cell manually operated or fully automated. Fixtured systems are very fast, ultra reliable. We prefer to promote fixtured systems because of their reliability in high production. Also today, it's very suitable for lights out assembly. Generally, available only on electric drive nowadays with some smart screwdriver technology. Pneumatic drive fixtured are pretty much gone away. Generally, issues with screw feeding are either part inaccuracies, a bit more on that later, or as a result of operator error. Fixtured screwdriver feeders fix this issue. So we have 4 primary types of fastener control in screw feeders. One shut or shut off clutch, current control, transducerized, or inserted to depth, or known as depth control. One-shot clutches are reliable and have good torque repeatability. You can get a signal that they have activated the clutch, hence reached a preset torque, but there's no real error-proofing capability other than that signal. Current control systems have most of the features of the better transducer systems, but they are not as accurate. And depending on the type of joint, they can provide a false result. Current control systems will also store the rundown data for quality audits and trend analysis. Transducerized systems are extremely accurate and can be calibrated to NADA certified instrument. They also have an inbuilt angle encoder, which can detect changes in the rundown signature. This will alert to a failed, crossed or stripped thread, damaged screws or parts out of tolerance. Transducer systems will also store the rundown data and quality audits and trend analysis. They're the ultimate solution for complete error proofing. The equipment used to calibrate and check your screw feeder or any torque control tools needs to be tested against a known standard. Our torque testing equipment has been calibrated in NATA certified laboratories and carries a current certificate of calibration. Therefore, the torque tools calibrated by Hawker Richardson are traceable to a NATA certified instrument. Shameless plug, but Hawker Richardson can calibrate screw feeders or any torque tools that you may have in our service centre in Melbourne. Again, generally there's three types of nose pieces on screw feeders: feed while you drive, self-advancing and telescoping. All I'll explain now. Feed while you drive. So in item 1, a screw is blow thread through to the flexible tube to the nose piece. Number 2, the screwdriver bit advances forward. Notice that it has pushed the arm out of the way. Number 3, the next screw is being delivered to the arm while the screw is being driven to torque and blocked. Number 4, as soon as torque is achieved, the screwdriver bit retracts and the next screw just drops from the swing arm into the nose. It only has to travel an extremely short distance. Self-advancing is a bit similar to feed while you drive, but it's just not as fast. In number 1, it must wait for the screwdriver bit to retract to the home position before the next screw is ultimately blown to the nose. In the second slide, the screwdriver bit automatically advances to position behind the screw head and holds it. This is known as headlock. And number 3, it enables the screw point to hold and be used to locate the screw hole or be used in an inverted position. Not as reliable as feed while you drive, as the air blast needs to be regulated down so the screw does not bounce back in the jaws, which can then cause misalignment. This lower pressure means that the feed tube length has to be limited. Finally, telescoping. Not the ideal solution, as the operator is required to apply an additional force to compress the spring-loaded nose piece. This requires the jaws to be pressed against the workpiece to counteract the spring in the nose. The jaws then open while being pressed against the workpiece, which will often cause scuffing or marks to the parts. Additionally, the screw is not locked in position with the drive bit, which can make location of the hole difficult. Another disadvantage of telescoping system is basically operator fatigue, but it's the most cost-effective solution. Most screw feeding systems are limited to just screws where the screw overall length must be a minimum of 1.5 times the screw head diameter. Engineering can be used to get this to a ratio of 1.25 in some circumstances, ideally not a handheld driver. But by using profiled tube and specially engineered nose pieces, we can easily handle screws with any head diameter to length ratio. Even hexagonal nuts, clips can be fed using profiled tube. Here's some examples of the many different fasteners that Weber can feed. See the variety of feed tubes and the shapes? Most screw feeders only use a simple round tube. There really is no type of clip, nut, or any fastener a Weber system cannot feed. Here's a simple example of how a heavy-headed screw travels through a profiled feed tube. If this was in a normal round tube, it would have a tendency to tumble and jam. Next, we'll look at some typical solutions from our long-term partner, Weber of Germany. Weber's the world leader in fastener feeding technology, with offices and facilities all around the globe. Just a quick reminder, if you've got questions, please put them in the box. This animation gives an example of some of the process. Step feeders are a gentler process than vibratory feeders, excellent for long parts or parts that are sensitive to scratching or scuffing. Vacuum and specially manufactured adapter holds and aligns the screw vertically by the head. The adapter advances well clear of the jaws and allows screws to be driven close to obstructions such as vertical faces or deep recesses. Weber systems have an advanced process control and error proofing, data storage, rundown traces, OK and OK signals with error codes. Weber handheld are the fastest available self-advancing feed while you drive technology. Available with vacuum for austenitic fasteners and or for difficult to reach locations such as hard up against the vertical faces we just saw or deep access. They can do nut feeding and heavy head screws. Error proofing and screw counting is all available. An example of the handheld range from Weber's systems will handle torques up to 5.3 Newton meters. Strokes of up to 128 millimeters or 5 inches in the old language will allow us to get into some deep recesses and hard to get hole positions. It should be noted, handhelds are best suited to simple applications as operator skill can influence a successful implementation as mentioned before. Difficult applications are best handled in an automated assembly cell with fixturing or even robotics. Fixtured systems are designed for automated assembly cells. The SER models just have what we call bit stroke, so they're usually used on a robot application, where the robot can position the screwdriver to the workpiece or vice versa. SEB models have the bit stroke and an additional slide as a head stroke. The head stroke moves the entire screwdriver and is used in conditions where screwdriver needs to move away from the workpiece to avoid obstructions when moving for the next screw. It's important to note, for ultimate reliability, unless using vacuum on a fixtured Weber, that the screw point needs to be situated very close to the workpiece prior to the screw driving operation, usually 1 to 2 millimeters to ensure correct alignment and engagement of the screw into the screw hole. We use Weber SEM or SEK units for nuts, heavy head screws, plugs, threaded inserts, etc. Here's some examples in a picture of a Weber SEM SEK fixtured system with torque capabilities up to 60 Newton meters. You'll notice the fastener coming in from the side through the profile tube. Weber have developed a world-first integrated collaborative screw feeder, fully enclosed in a plastic molded casing. No sharp edges or exposed moving parts. Ensure a safe working environment for the operator, controlled by sensors. So the next slide will show you a video of the collaborative SEVC in action. Excellent video, huh? Even down to the groovy music. Weber has vast experience with bowl feeders, available in a number of different materials depending on the fastener weight and size. All of the systems supplied in Australia and New Zealand come with a soundproof enclosure as standard. The bowl is a hard-wearing nylon with rubber inserts at wear points. It's worth noting in Australia that over 25 years of applications, some bowls working 24/5, 24/7, we've never seen a worn-out bowl. Step feeders have a larger storage capacity and also very good for longer screws. A gentler process with low noise and minimal vibration makes them suitable for long parts, sensitive parts, and parts where surface finish cannot be damaged from parts rubbing together. Now across to Rob in the demonstration room with a display of the Weber handheld and fixtured systems.
Good. Thank you, Jim. Good morning. My name is Rob Plagman, Managing Director here at Hawker Richardson. We've crossed over to our display room to demonstrate the features and the Weber bowl feeder and screw feeder systems. This bowl feeder is equipped for the specialised high-speed feeding of screws and parts. The feeding system is one of the key components when it comes to the reliability, efficiency and capability of the automated assembly process. Here we have a typical bowl feeder system. This is the Weber bowl feeder system. As you can see, we have a sound enclosure. Inside, we have a drive and a bowl. Now, these would be sized appropriately to your parts or your screws. From the bowl feeder, you would go through an escapement. From the escapement, you would go down through the tube, as Jim discussed earlier. Here's two types of tube, your typical round tube for screws, and here's the T-slot tube that you saw on the slide. From the tube, you would end up at a driver like this. This is the HSP Weber handheld screwdriver. Pneumatic driver, easy to use, nice big trigger on it. Feeding system, swivel arm, and in this particular model we have a two-piece jaw system. This is the ideal handheld screwdriver for your typical wood screw, for example. From there, we can look at automated systems. This is the SEB unit from Weber. Think a XY style robot. This particular unit would be the Z-axis. It's got its own bit advance. It's a very modular system using the Carslon nuts here. We can add motors, transducers. We can replace transducers and motors while in a robot application to swap them out for calibration, for example. As we move down, you can see the modular system continues. We've got quick change heads on them. We've got the swivel arm, unique to Weber. This particular unit is using a three-piece jaw system. There's just a couple examples of the Weber screw feeder system. Back to you, Jim.
Thanks, Rob. You saw a little bit of an example there of the quality, the extremely high quality of the Weber system, the modularity of how it works. Our other partner in automation is Carslon Engineering and Manufacturing of California. All the Carslon systems are manufactured in their own facility in the US of A. Carslon are a robust and very reliable system. Here's some examples of Carslon fixtured screw feeder systems. Single cylinder systems have just the bit stroke, as we discussed before. Twin cylinder systems for bit stroke and head stroke to move the whole screwdriver to position. Strokes can vary in length and be actuated via air cylinder or even a programmable electric actuator. completely negating the need for pneumatic air. Carslon systems are capable of feeding very large bolts and extremely high torques. Carslon bolt feeders and escapements are simple and effective, available in a variety of sizes, suitable for long screws or bolts. All the systems, again, include a soundproof enclosure. For longer screws or parts that are sensitive to marring or scratching, Carslon also manufactures step feeders. These are typically a more expensive option, but have the advantages as previously discussed. Again, we're going to cross to Rob with a demo of the Carslon unit screwing in self-tapping screws into a polyethylene block.
Okay, so the Carslon auto feed screw feeder system are ergonomically, operator-friendly, enabling manufacturers to quickly, efficiently fasten parts together with ease. Here we have a display Carslon screw feeder system. Again, we can see the soundproof enclosure. Again, we can see a drive, a bowl, an escapement, the feeder tube, and in this case, the feeder tube's running up through our ergonomic arm down to our driver. As you can see, it's a very ergonomic solution. Easy to use, easy to operate. I'm going to give you a quick demonstration on how easy this thing is to use. Very fast. It's very efficient. You could do this all day. Back to you, Jim.
Thanks, Rob. How to find out what screw feeding solution is suitable for you. We can email you an RFQ questionnaire to qualify the application, come and visit you, have a web meeting or Teams or any scenario like that to discuss it. The more information we have, the more refined our proposal can be. Besides the exhaustive list on screen, paramount to effective operation is access to the hole in the part and the fastener quality. Fastener and part repeatability, whether it be in the part or the jigging and accessing of the part. It was once explained to me from a supplier that although handheld screw feeders made up some 50% of the units that they sold, they accounted for over 95% of the problems that returned due to screw feeding. And this is largely down to operator issues. So it's important to get it right and get the right solution for you. The other consideration before you even make the part is design for manufacture. When designing a product, think about screw dimensions and locations and commonality of screws. If you're planning to mass produce the part, try and make it easy for automation. Some hints for designing for manufacture: follow these guidelines and they will save you the cost on assembly. Ensure screw holes have a lead-in chamfer to help the screws in. Ensure the screw length is approximately 1.5 times longer than the screw head diameter. If the screw is has to be placed next to an obstruction, we'll have to have vacuum generator, additional adapters to hold the screws, longer bit stroke, and these all add to cycle time and cost. So again, the simpler you can make the part, the better it will be. Now to the questions. I don't know if we have any questions, but if you do, please type them in and we'll endeavour to answer.
Hello, my name is Martin Gillespie. I handle the general automation products from Hawker Richardson. We have just one question at the moment, and that was how long does a Weber last? Pretty broad-based question, but we have Weber units in operation. Some working 5 days a week, some 7 days a week, dual and triple shift operations on some of them, and we know that we have some units that have operated in excess of 17 million cycles and still going strong. So that might answer the question. They are extremely reliable.
Hey Marty, there's a question here come in. What is the most suitable screw to use in screw feeding?
Okay, typically screws with a female recess generally work good. Something like a Phillips or a Torx work really well. So so Phillips or Phillips, Aussie, or Torx work really well. Hex heads work okay as well. Hopefully that answers that question.
Another question here, Marty, is what is the maximum noise level from the feeder bowl inside its casing?
Okay, I couldn't really tell you exactly what the dB rating is, but with the nylon bowl and the soundproof enclosure, it's very, very quiet. There's hardly any noise whatsoever. You could have it operating in for instance, a electronics clean room, and it wouldn't cause any duress to the surrounding operators.
It's also important to note that the bowl doesn't continually run. It only feeds the screw a very short distance to the escapement. So if it has 6 screws it might run for 30 seconds initially, and then it'll have a dozen screws in the escapement ready to go. So each operation will only run for a second really to put the screw into the escapement. Generally, that shot of air is what you hear is more louder than the actual vibration of the bowl. I have another question here from Marco. What is the minimum distance between the screw head and the wall with a vacuum pump assembly?
Okay, that kind of depends on what sort of head it is. If you can imagine, if you're maybe a hex head, you would need a larger holder, if you like. But generally, we can get extremely close to the vertical face if we use a 2-jaw system and we have the jaws opening adjacent to the wall. You would generally find we can get within a few millimeters of the wall.
I have a question here. Does Weber have nut feeders as well? And if yes, for standard hex nut?
Yes, we do. Weber can manufacture nut feeders for a standard hexagon nut, and they're available in handheld or fixtured units, and they feed very, very reliably. No issues with them at all. Weber were the first to introduce nut feeding technology, probably back in the mid 80s, I would say, and had that system patented for many, many years. I'm not sure if the patent is still valid, but not too many other manufacturers even attempt to feed nuts. Weber are the specialists at nut feeding.
Yeah, it's worth noting that we've had Weber for over 30 years in Australia. We've had systems at Ford, Borg-Warner, DSI, Clipsal, HPM Legrand, Dana. These have been used extensively. Corinthian doors extensively for 25, 30 years in some facilities like Clipsal and HPM. They're an extremely reliable system. I think that's about it for the questions. So without further ado, I'd just like to say thanks for attending and your participation. I'd also like to thank some people for today's production. Our marketing manager, Victoria Laws, and business development manager, Martin Gillespie, there for the extensive work on this PowerPoint. Maria Trokowski, our marketing coordinator, for putting the whole production together today, and Rob and John for the technical live demonstrations of the Weber and the Carslon unit. And of course, Weber and Carlson themselves for providing a lot of the content. So thanks very much. I hope you got something out of it. I think this will be available for download shortly through a link that will be sent out to you. So enjoy your day, and thanks for your time.